We're back with another section of circles, 10.6. This is more angle arc theorem. So we're going to take some of the stuff we learned in 10.5 and expand on it a bit. The first thing that we are going to address is Theorem 91, which is that an angle inscribed in a semicircle is a right angle. So let's look at angle BCA. The vertex of this angle is on the circle, which means its measure is half the arc it intercepts. Well, this angle is intercepting arc BA, which is a semicircle. That's 180 degrees. Half of 180 is 90, which makes this a right angle. Well, when is that helpful? Let's look at this practice problem 1. In circle P, this should say BC is a diameter. AC is 12, BA is 16. Find the radius of the circle. Well, this angle BAC intercepts a semicircle, which makes this a right angle. So I can use Pythagorean theorem or my knowledge of triples to find BC, which is the diameter, and that is 20. If my diameter is 20, my radius is going to be half that, or 10. Okay, moving on to Theorem 92. This one says the sum of the measures of a tangent-tangent angle and its minor arc is 180. Now remember, a tangent-tangent angle means that I have two tangent segments drawn from the same external point outside my circle. And so what this Theorem 92 says is that the measure of angle P plus the arc it intercepts, TS, add to 180. So let's look at problem 2, and we're going to use that knowledge. Given PQ and PR are tangent segments, which means I need to draw this in. I'm going to have a circle. And because I have PQ and PR, that tells me P is the external point that they're both drawn from. So there's PQ, there's PR. And if arc QR is 163 degrees, find the measure of angle P and angle PQR. Let's find angle P first. Because this is a tangent-tangent angle, that means angle P plus the measure of arc QR add to 180. I know arc QR is 163, so if I subtract that from 180, I get that angle P is 17 degrees. Now onto the second part, angle PQR. Here's angle PQR. I'm going to highlight it so you can see it more clearly. Angle PQR. The vertex of that angle is on the circle, which means its measure is half the arc it intercepts. It is intercepting arc QR, which I know to be 163 degrees. So angle PQR will be half of that. And half of 163 degrees is 81.5. Okay, on to our last example for this set of notes. Given PY and QW are tangents, now let's talk about which circle they're tangent to. Tangents only touch the circle at one point. So they're tangent to this smaller circle, but not the larger circle. They are secants of the larger circle. Arc WZ is 126 degrees. Arc XY is 40 degrees. And we want to find the measure of this arc right here, PQ. Now, let's analyze this a little bit. Arc PQ has a tangent-tangent angle out here. Let's call it angle 1. So those two would add to 180 degrees. So if I can figure out the measure of angle 1, I can find arc PQ. Well, this angle 1 is a vertical angle to this other angle. And if I'm looking at just my circle on the right, that is an angle where the vertex is outside the circle. Remember, when the vertex is outside the circle, the angle measure is half the difference of the two arcs. I know the measure of those two arcs, so let's find this exterior angle. 1/2 of 126 minus 40. That's going to be 1/2 times 86, which is 43 degrees. So this exterior angle is 43 degrees. It's vertical to angle 1, which means angle 1 is also 43 degrees. And again, tangent-tangent angle, minor arc, those two would add up to 180 degrees. So what I can do is subtract 43 from 180, and I find that that arc is 137 degrees. And that's it for our notes on 10.6.